Today we are working hard. Okay, so we're going through all the solving types from logs and exponentials. All the solving types. So the first one is like this. And I'm not going to tell you how to do all of these. I'm just going, I will after, but I'm not going to tell you right now. You have to try and do them yourselves. What's your first solve? Your second solve is like this. I just want you to look up here for a second. So just to start you off, there's no equal signs running down the middle because I have an equal sign, or down the left, I have an equal sign in the middle, right? So this would be 5 to the 2x plus 1, everyone's good at that, times 5 to the 3, and then I have to remember to put this in a bracket because it has to go the whole thing, over 5 to the 2 to the 3x plus 1. Now, 125 is 5 to the what?
3.
Okay, so this equal sign to this stupid spot. So this would be 5 to the 3. And what is the square root as an exponent? We talked about this in grade 10 and we keep talking about it in grade 12. It's to the half. So it would be 5 to the 3 to the half, and then in brackets 2x plus 4. And on the bottom I would get 5 squared to the 3x minus 6. So this 3 halves joins first. I'm going to be left with 5 to the 3 halves. And then I have to put that into 2x plus 4. So those are my hints. Now, when am I allowed to drop the base off? Yeah, so not when all the bases are the same, when there's only one base on the left and one base on the right. So when I have 5 to the something equals 5 to the something, 1, 5, then I can drop the 5s off. So I'm going to have to combine all these exponents first, because what's the rule of exponents? If they're in the numerator, you add them, and if they're in the denominator, you subtract them, correct? So you're going to end up going 5 to the 2x plus 1 plus 3x minus 9 minus 6x plus 2, right? Like you have to put them all together with plus and minus signs first. You do not just drop it off and multiply these exponents and divide it by that, which is what everyone will do, and that's a common error, okay? You have to combine your exponents first. So try that out. Can we check all these solvings? Y1, Y2, every single solving, doesn't matter what I give you, you can check them. So you should be sad or happy. Okay guys, there are still some people who don't know how to study. They've gone through life for a long time and they study, but it's not the best conducive studying. Now, if I give you one of each solving to practice how to do it, right? Does that mean you have to go find out? People will be like, can you give me 700 more examples? Do you need 700 more? No, you need to be able to do this question. You need to be able to do this question without thinking. You need to be able to do this question without going, oh, at this point I now just drop it off and I go 2x plus 1 times 3x minus 9 over 6x plus 2. So how do you do that? Well, you cover up your entire solution and you try it again until you don't have to look back. You don't need 700 examples. You just have to be able to do this example without thinking, right? Because I should be able to switch all the numbers. It's not, people aren't getting hung up that 125 is 5 cubed. That's not what you're getting hung up at. If I change the example, that's all I'm changing. I'm changing those numbers and you're getting hung up as to what to do with your steps. So when we get here, this is the common error. People will drop this off now and they'll go 2x plus 1 times 3x minus 9 over 6x plus 2 every single time. And that's not what you're supposed to do there. So how do you study? I give you each solving type. You go home, cover up the answer, and try and do the question again. I promise you don't have it memorized. Okay? That's how you study. So you can do it without having to think. Then you do that tonight. Then what do? Tomorrow you try it again. And you see, can I do this without looking back? That's how you study. You cover up the solution. You don't need 700 of this type of question. You need one that you can do well. Okay? I promise you, you're not getting hung up that 25 is 5 squared. So if I'm changing it, that's the only difference that's happening, right? Okay. So I have to put these together. Anything that is on the numerator gets added and the denominator gets subtracted. So I'm going to get 2x plus 1 plus 3x minus 9 minus the denominator. So when I minus 6x plus 2, what do I get? Negative 6x, then what? Plus 2? I'm subtracting the denominator. I'm subtracting this, yes. I'm going to get minus 6x minus 2. When you subtract, it changes the signs of everything, right? So minus 6x minus 2. Here I'm going to have 3 halves times 2x is 3x. And then 12 plus divided by 2 is plus 6 when I distribute that through. So it ends up actually being something nice, 3x plus 6. So I'm going to get 5 to the 3x plus 6. And then I have to subtract the denominator. When I subtract the denominator exponent, I get minus 6x. Now I'm subtracting a negative 12. So what am I going to get? Plus 12. Then I get together all my exponents. So I get 5. 2x plus 3x minus 6x is negative 1x. Plus 1 minus 9 is negative 8. Minus 2 more is negative 10. Equals 5 to the negative 3x plus 18. Now and only now can I drop those 5s off, right? Because I have 5 to the something equals 5 to the something, so the somethings must equal, right? So now I get negative 1x minus 10 equals negative 3x plus 18. Add 3x. And I get 2x minus 10 equals 18. Add 10x, or add 10, sorry, not 10x. 2x equals 28. Divide by 2, x equals 14. So my x max on my calculator needs to be at least 14, right? I'd make my x max be 15. And then how do we check this? y1, y2, the original, right? Second trace 5, enter, 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 and you should get 14 every single time. So we can check these. Okay, the second one is an exponent exponential equation with one exponent. Exponential equation with one exponent I can convert to a log. I know that. I should know that. That should pop into my head immediately. Exponential equation with one exponent I can convert to a log. How can I convert to a log? I must only have 3 pieces of information. I currently have a 4, a 6, an 8, and a 2x plus 1. That's 4 pieces of information. I can't convert until I have 3 pieces of information. The 4 can't join the 6. The 6 has an exponent. The only way you can make anything with an exponent combined is just like our last example. It has to have a common base. That is not a common base. So I cannot do that. But I can divide the 4 over. Why can I divide the 4 over in this case? Yeah, because 8 doesn't have an exponent, and 8 divided by 4 is something we learned about in grade 3 that we could do, right? That's a grade 3 math skill that we're like, hey, 8 divided by 4, I've heard that before. That seems okay. That's why we can do it. So now we have 6 to the 2x plus 1 equals 2. Can I make them a common base? No. Can I convert to a log? I have 3 pieces of information? Yes. So I get the base of my exponent becomes the base of my log. So I get log base 6. Friends don't say friends. So I get a 2 and I put it in brackets. Equals 2x plus 1. And then I just subtract 1 from the whole log. Log base 6 of 2 minus 1 equals 2x. Divide by 2. X equals this. You would round to whatever they ask. They could ask for exact values. Remember that when you're dividing by 2, you could divide each term by 2. So what would that mean? That would mean log base 6 of 2 divided by 2. I'm just showing this to you because they can give it in any form they want. Minus 1 over 2. What's dividing by 2 the same as? Multiplying by 1/2. So they could write it like this technically. Say you're stuck. It's a multiple choice answer. It's not a numeric response because that could rip you off. But it's a multiple choice answer. Could you not turn your answer into a decimal, turn all their answers into a decimal and match them? Yeah. Yeah. The only time you can't do that is if there's a variable involved, right? So these are two types. One you can make common base, one you can't make common base with an exponent. One exponent, correct? Okay, what are the other ones? Here's 2 more. Number 3 is when I give you 4 to the x plus 3 equals 3 to the 2x minus 1. Can I make common base? Is there only one exponent? No, so I can't make common base. I can't convert to a log. What do I have to do? Log base 10, both sides. Correct? Okay, that's number 3. Number 4, 2 times 3 to the x minus 1 equals 4 to the 2x plus 1. Can I divide the 2 over? 4 is an exponent. Can I make the 2 join the 3? 3 has an exponent. So what am I going to have to do? Can't make common base. Log base 10 both sides. There's that extra step, though, where you have to separate them with an addition sign. So remember, when we log base 10, there's just one extra step when it's like this. We go to our formula sheet and we say, hey, Mrs. Lepp taught us, Mrs. Lepp taught us that when there's 2 things multiplied together in a log, we can separate them by addition. It's the multiplication law of logs. You have a formula sheet that tells you that. Log b of m times n. Cool, 2 things multiplied. It could be 3, 4, 5, doesn't matter. I can write them out being added every time. So this is that extra step that everyone forgets how to do. You get log base 10 of 2 plus log base 10 of 3 to the x minus 1 equals log base 10 of 4 to the 2x plus 1. And now you're in the same boat as number 3. Just as that extra step where you have to add them because you have 2 things multiplied in a log. Okay? Working through both of these. Try them out. Exponent in front, all that jazz. Now my hint to you when you were doing these, guys, was take your exponent, drop it in front in brackets. Because when that exponent is in brackets, that binomial's in brackets, it screams distribute, right? If you don't put the binomial in brackets, it doesn't scream distribute, and you sit there and stare at it. This is the spot where people get stuck. On the second one, it's this red spot where they don't turn into a plus. But here, they'll drop the exponent in front if they get to this point, and then they're like, I don't know what to do. So remember to put your exponent in brackets. If you're still getting stuck on these steps, is this one question I'm reviewing with you just right now enough for you to do well on the test on Wednesday? No. No. You have to take the question and do what with it? Practice it. Cover it up till you can't make mistakes, till you know all the steps. I see this. I can't make common base. I have 2 exponents. I have to log base 10 both sides. Cool. Now I have to take my exponent. I have to drop it in front in brackets. Cool. I have to distribute. Yes. I have to get my x's to one side and everything else to the other. Why? So I can GCF an x out. Awesome. Then I divide over. Yes. Then I can put it together as a log. Awesome. I have an answer. If you can't do that right now, at the end of this, you are not good enough with it. You need to practice more. You have a test on Wednesday. I'm trying to show you what you do and do not know. If you don't know how to do it, that means you need to study more. That's all that means. And I can't study enough. Like, I can't go through this question 400 times with you. That's a you thing. Next year, no one's going to even do this for you. You'll have a 40% midterm, a 50% final, and something worth 10. That's what you will have. So if you don't study on your own and figure it out how to do it, you're going to be in trouble. So what you have to do is you need to break down all the concepts of what your prof has taught you. Go through and be able to do them till you can't make mistakes. And then go to the test and you'll do fine. That's how you study math or any sciences. Break it down into a flashcard and study that baby till you can't make oopsies. That's what you do. And if you're still guessing what your next step is and you have to look at the paper to see what it is, you're not in a good spot for the test. You have to not be able to look down and see, oh, right, I have to drop that. If you go, oh, right, I have to put that in front, you're not doing this on the test. You will get stuck at that spot, right? You have to go through and be able to execute the whole thing without having to look back and say, oh, right, I have to drop the exponent down. If you go, oh, right, I have to drop the exponent down, you're not getting this right on my written response. I know you're not. Okay? You have to be able to do it without looking. Now, if I just want it as a decimal, we would stop here. If they want it as a single logarithm, you got some work to do. They might ask for it as log something base something. So what do we have to do? We have to put the top together as a single log and the bottom together as a single log. If they want a decimal, you would just type it in right here, you'd have an answer, right? If not, you have to put them together as a single log. Now remember, this would be 4 to the 3, because the exponent has to come up. And this would be 3 to the 2, because the exponent has to come up. So I'm going to rewrite it like that. So I get negative log base 10 of 3 minus log base 10 of 64 over log base 10 of 4 minus log base 10 of 9. Now, if we have the same base, it screams, put me together. You can put anything together that has the same base, right? Anything with a minus 1 in front, what's beside it goes in the denominator. Anything with a plus 1 in front, what's inside it goes to the numerator. So I would get log base 10. They both have negatives in front, correct? So what's in the numerator then? Trick question. A 1. In the bottom, I'm going to have 3 times 64. Then this one, I have log base 10 of 4 over 9. Which is the same as log base 10, 192, I believe. 1 over 192. Now, when you get stuck here and you're like, oh gosh, I don't know what to do, there's a formula on your formula sheet. Remember, you can go to your formula sheet. It's there. It's there for a reason. So if I have, here it says, log base A of C over log base A of B, if my A's are the same, which in this case are 10, I can just write the B as the base and the C beside it. The A's don't appear anywhere. So what's up here would go beside the log, and what's down here would go in the base. So these 10s don't appear anywhere. This is going to go beside the log, and this is going to go in the base. So I'm going to get log, and the 10s don't appear anywhere. 4 over 9 is in my base, and 1 over 192 is beside it. Because they might say, determine this in the form log A, B, and then ask what A and B are. Stuff like that. Now, can we still know we're right? Sure. We could type our original in, left y1, y2, get an answer, right? Type this in and get an answer, and the decimals should match. You should know. And you can do that in solving. The greatest thing about solving is you can y1, y2 every single step. And the moment you don't get the actual same decimal, that's where you oopsied. So whenever you solve, you can go y1, y2, get a decimal where they intersect. y1, y2, get a decimal. Cool, they're still intersecting at the same spot. y1, y2, still intersecting at the same spot. y1, y2, whoops. This doesn't intersect at the same spot. Okay, here's my error. Go back to this step. This step was good. This step is bad. Erase everything below that. What can I do differently that can get it to match? Because every step should technically y1, y2 come out to the same decimal. So when they're like, which place did they error? When it's a solving question, those are the easiest. y1, y2, the first question. y1, y2, the step 1, same decimal. y1, y2, step 2, not same decimal. Errored in step 2. You actually have to know absolutely no knowledge. You can y1, y2 the crap out of them unless they're in variables. Okay, this one just had that extra step, and then we do the same steps all over. So I get log base 10 of 2 plus x minus 1 log base 10 of 3 equals 2x plus 1 log base 10 of 4. Distribute. And I get log base 10 of 2 plus x log base 10 of 3 minus log base 10 of 3 equals 2x log base 10 of 4 plus log base 10 of 4. So I am going to, I have 2 logs on this side and 1 on that side, so I'm going to subtract this one. Because anything without an x goes to one side. Everything with an x goes to the other. I'm going to get log base 10 of 2 minus log base 10 of 3 minus log, well, it's going over 10 of 7. What's my next step then? I got the x to one side for a reason. Why? I have to take out that x, that GCF, that x just stays the same. Slide that over. Now, if it asks for decimal, you'd be done. You type it in. If it asks for an exact value, we have to get these together, and I'm going to bring this 2 up here. Because the only way you can put logs together is if they have plus or minus 1s in front. If they have a number in front, you have to bring it up to the exponent. So, here I'm going to get log base 10. It's just for the numerator. 2 goes in the numerator. 3 goes in the denominator because there's a minus sign. 4 goes in the denominator because there's a negative sign for the log. Anything time there's more than one thing gets multiplied. On the bottom, I get log base 10, 4 squared, so 16 goes in the numerator, and 3 goes in the denominator, and this equals x. So now I have log base 10, 2 over 12, or I get 1 over 6. Log base 10 of 16 over 3. And if they're both the same log base, this goes beside the log, this goes in the base, the 10s just drop off. So I get x equals log base 16 over 3, 1 over 6. Now, if you take them to the other side, like you know how I took the x's to one side and the logs to the other, say you flip-flop them, you take them to the other side instead, these fractions just flip. So this will become a 6 and this will become a 3 over 16. That's all that happens. So if you move it to the other side, the fractions just flip. Because instead of subtracting, you're going to be adding on the other side, right? So keep in mind you get the single logs, but you'll get fractions that flip. So these are just, all we did right now is we did all the exponential solving. We haven't solved the log yet. There's exponential solving where we can make common base. Exponential solving with one exponent, convert to a log. Exponential solving, two exponents can't do common base, have to log base 10 both sides. Then there's some more. So this would be 3, 4, 5, 6. We'll be solving logs. These ones should be quick. Why should these ones be quick? There's a single log, so what do you be able to do? Transform it to exponential. When it's a single log and you don't know the base variable or the variables beside the log, it's a convert to exponential situation. But what are we going to have to do first? Divide the 2 on that one and divide the 2 on that one. Because we have 4 pieces of information and we can only have 3 to convert. Okay, the base of your log and what's beside your log can't be what? Okay. No, but the base of your log and what's beside your log can't be what type of number in the number system? Negative or 0. They can't be 0 or negative, correct? So before I start this one, I have to say x plus 1 has to be greater than 0. So x has to be greater than negative 1. And this one I would have to say 2x minus 1 has to be greater than 0. 2x has to be greater than 1. X has to be greater than a half. If I divide by a negative, that's the only thing that switches that inequality sign, right? So we have to make sure we state our restrictions. Now, some people are asking me, do I have to divide the 2 over to the 6, or can I bring the 2 up? Well, because you have a log, you have options. When you have a log, you can bring it up as a power rule, or you can divide it over, right? And both of those would work in this instance, because 6 divided by 2 is legal, and 3 squared is 9. You'll get the same answer depending on which route you went. So because most people divided, just let's see if you get the same answer, because I'm going to bring it up as an exponent to prove a point. So I can go log x plus 1, don't change yours, because I'm sure it's the same answer, of 9 equals 6. And then I convert x plus 1 based on my log to an exponent equals 9. And I would take the 6th root or raise it to the power of 1/6. And I get x plus 1 equals 9 to the 1/6, or the 6th root. I'm just proving a point. It can be either. Minus 1. And what do we get? Anyone get an answer? You're getting an answer, but none of you are doing it because you're scared you're going to be wrong. Remember, y1 and y2, you shouldn't be scared if you're wrong. You can check these if you're comfortable. Right? You should know your answer is good or it's crap. There's no in between, right? Y1 and y2 should tell you, yay, or like, ah, this one I'm going to divide the 2 over to prove point. If I brought it up as a 2 here, I would have to square root, so it doesn't matter. And I'm going to divide by 2. Let me show you that I can do either way. So I get 4 equals log base 4 of 2x minus 1. Convert now because I have 3 pieces. So the base of my log, which is a 4, to the base of my exponent. My exponent is not, because they don't stay together, so I'm going to get a 4. Equals 2x minus 1. 4 to the 4 is 256. Equals 2x minus 1. Add 1. 257 equals 2x. Divide by 2. X equals 257 over 2 if they want exact values. Or 128.5. Okay, last two solving we haven't done yet. Logs. Yeah.
How do you know, like, something to give and, like, is exact value the decimal form?
Exact value is the opposite of decimal.
Okay, so when they say decimal form, if that's what they want?
They'll say round to the nearest tenth, hundredth, thousandth. They'll give you a rounding rule. If they say exact value is the opposite of a decimal. Now, 128.5 is actually technically an exact value because it stops. A terminating decimal is an exact value because there's no, you can't choose it, change it, switch it, right? But a non-terminating decimal or a repeating decimal, once you round it, that's not exact anymore, right? So like 0.33333, if you rounded 0.33, you've rounded it. It's not an exact value, but 1/6 would be an exact value. You know what I mean? Or 1/3 would be an exact value for 0.333, right? So if you round, it's not exact anymore. So they'll ask for the nearest tenth or hundredth or thousandth. If they say exact value, it's a fraction. You could get away with 128.5 being an exact value because that is exactly what 257 over 2 is. Exact values often comes up in like when you have to use the quadratic formula and then people round it to a decimal. The moment you take the quadratic formula and you round it to a decimal, it's not exact anymore because you rounded it. Does that make sense? Okay. All right. 7, 8. These are your last two solving types. So I can give you one that's all logs, and give you one that has some logs and then some not. So this one has some logs and some not. So you're going to get all the logs together because they're log base 2. And when they're log base 2, it screams, put me together, right? And you have the same base. You can put them together. Or I can give you one that's just all logs. So guys, on your test on Wednesday, you have to spot log base 2, log base 2, and then you're like, why the heck would she make them both be log base 2? That's just silly. She made them both be log base 2, so you put them together. That's it, right? You see log base A and log base A, put it together. Log base smiley face, put it together. Log base 3, put it together. The only reason why they're the same log base is to put them together, right? That's the point. It needs to scream that to you or it's going to be a struggle. So I'm going to put these on the same side because they are both log base 2, so I can put them together. Now guys, this is something I want to pay attention to because this I think caused mass confusion, so I just took a break for a little bit. So we know that what's beside a log or what's in the base has to be greater than 0. We know that, right? It can't be 0 and it can't be negative. So I told you could take these two things. X minus 2 has to be greater than 0. And x minus 5 has to be greater than 0. And so x has to be greater than 2, and x has to be greater than 5. And I said if this was a written response, I would just box both and be like, cool, that's great. But if it's a multiple choice, they'll give you one of the two that works for both. Now this is what I do if I'm stuck and I don't know which one of the two. Take a test value. Okay, is everyone paying attention? You're going to take a test value. So my first one is x is greater than 2. What is an easy number greater than 2? Just over greater than 2. 3. Just over. We don't want to pick something ginormously over because 10 is actually over 5 as well. I want something that's over 2 but not over 5. Like I want it to just fit that one restriction, correct? So what's greater than 2 but not greater than 5? The number 3. Now what I'm going to do is I'm going to try and plug number 3 back in and see if it would actually work for my logs. Both logs. So I plug a 3 in here and I would get a positive number, right? Cool. What if I plug a 3 in here? No. So does the x is greater than 2 actually give a good restriction that will work for both? No, it only works for the one log. Okay? Let's test the other one. Because I can keep both if it's written response. I can just write both. Cool. If it's a multiple choice, they're going to pick the one that works for both. Okay? So now I need to pick something greater than 5. What's greater than 5? 6. Okay. 6 minus 2, positive, so it works for that one. 6 minus 5, positive, so it works for that one. So which of the two restrictions works for both logs? X is greater than 5. So if it's a multiple choice answer, that's the one they're going to list. Because the x is greater than 2 works, but if it's not a standalone. Because if I use x is greater than 2, 3 doesn't work for the other log. Okay? So list both of your restrictions and then do test points to figure out which one works for both and pick that one if it's a multiple choice. Okay? Cool thing is, if they give you a multiple choice answer, if it's multiple choice A, B, C, or D, you can run test points of that and see which one actually works for the question that you gave you, right? You can work your way backwards. All right, so that's the one that I would pick that works for both, that x is greater than 5. Now they're both log base 2, so I can put them together. This one has a plus 1 in front, this one has a plus 1 in front, so they're both going to end up in the numerator. So I'm going to get log base 2 of x minus 2 times x minus 5 in brackets, so I know that they're both beside my log. And it equals 2. I have a single log. I don't know what's beside the log. What do? I have a single log. I don't know what's beside the log. What do I do next every single time? Convert to exponential every single time. So I'm going to get 2 to the power of 2 equals x minus 2 times x minus 5. So I get 4 equals x squared minus 2x minus 5x. So minus 7x minus 2 times 5 is plus 10. This is just grade 11 now. Subtract the 4 over. And I get x squared minus 7x plus 6. And then I factor x minus 6, x minus 1. So x equals 6 and 1. I write them separate because sometimes both of them are solutions, sometimes neither of them work. Sometimes one works and the other one doesn't work. How do I know? I can look at my restricted domain. My restricted domain was x has to be greater than 5. That was my ultimate domain, right? So is 6 greater than 5? Yes, hence why 6 will work. If I plug 6 back in, I plug it in here. 6 minus 2 is 4. 6 minus 5 is 1. 6 works, correct? Now 1 is not greater than 5 and it's not going to work. So I plug 1 in. 1 minus 2 is negative 1. It's done. So some people are like, I don't know when to put no solution or extraneous. And by some people, I mean all of you. This one works. No solution means I went to plug it into the quadratic. Actually, I went to go factor it. I couldn't factor it. I went to plug into the quadratic formula. I got a negative under my square root sign. I have no solution. There is no solution that works. No matter how hard I try, no solution comes out. That is no solution. Extraneous is, I got a solution. It's pretty. I plug it back in. It sucks. It's extraneous. It's a solution, but it's extraneous. It cannot use it. No solution means I cannot get one. Extraneous means I got one, and it doesn't work when I check it. So, did I get one? Yes. Does it work when I check it? No. So is it extraneous or no solution? Extraneous. It is a solution. So you can't say, some people circle it and say no solution. I'm like, well, first off, there is a solution. It's x equals 6. Second off, this was a solution. You can't write no solution. It doesn't make sense, right? If you think about it in English language-wise, no solution means there's nothing, and I have, so that doesn't work, right? So it's extraneous. And honestly, that is a big struggle. Every single person. That is a struggle for every single person. Not just one student, it's for all of you. So if I can get you to understand no solution means I tried and I couldn't get one. X equals I could get nothing. Nothing there. No solution, right? I got something, it doesn't work, extraneous. If I can get you to leave 30 on with that, I feel like I'm winning. Okay? Okay. This one is all logs. So what could I do? I could move them all to one side and set it equal to 0, put them together, convert to exponential. Okay? You can do that, or you can put this together, leave this on this side. You'll have log base 5 of something equals log base 5 of something and set the something's equal. So I'm going to show you the two methods. I'm going to show you the one that's like this one first. So I could go log base 5 of x minus 18 minus log base 5 of x minus log base 5 of 7 and equals to 0. I could do this. I'm going to show you the two ways you could do this one. Because what if Bertha and Frank do it 2 different ways and they ask which one's right? You know what I'm saying? So we have to be able to do both. So we get log base 5. And x minus 18 goes in the numerator because it has a plus sign in front. X and 7 go in the denominator. And now I can convert 5 to the power of 0, which people think is 0. Is that actually 0? No, it's 1. X times 7 is 7x. So this becomes a 1. Then what's my next step? Multiply 7x. So I get 7x times 1 is 7x equals x minus 18. Add 18. That's a lie. I meant minus x. I don't know what I'm doing. X equals 18, negative 18. So x equals negative 3. And then I have to check it. Negative 3 minus 8. So I circle it. I put a line through it and I say extraneous. So when I actually type in y1, y2, are these graphs ever crossing? No. Now what was the other way I could have done it because they're both logs? Or all of them are logs? I could go log 5 of x minus 18 minus log 5 of x equals log 5 of 7. Because there's no numbers here, they're all log base 5s. I can combine the log base 5s on one side. So I get log base 5 of x minus 18 over x equals log base 5 of 7. Now, if I have log base 5 of this equals log base 5 of this, what can I say about those things? They're equal. So I get x minus 18 over x equals 7. Multiply my x up. X minus 18 equals 7x. Negative 18 equals 6x. X equals negative 3. Same answer. Same words, extreme. Now what if they want the restrictions, which sometimes is like the second part of a written response on the diploma? They want the restrictions of a log. Well, you just take what's beside the log. So I go x minus 18 is greater than 0, and x is greater than 0. So x is greater than 18, and x is greater than 0. Those are my two. What if they want to lump it together? Which one covers both? Well, let's try the number 1, which is greater than 0, but not greater than 18. 1. 1 minus 8. It's kicked out, right? It doesn't work for this log. Okay, let's pick 19. 19 minus 18, 1. 19, good. So it's going to be this one. That's going to be this one is going to be the ultimate answer for a multiple choice, if I'm only allowed to state one of them. If it's a written response, can I state both? Yep. But that's the ultimate one that works for both. So those are all the different types of solving that you have to be able to do. I gave you a question for each. You need to work through them until you don't make oopsies. Okay. I'm going to give you another question, but in the meantime, I want you to write these down because you need to study them. You need to be able to do increasing, decreasing word problems. Or appreciation, depreciation, where it's like increasing, decreasing. Where it's like there are 7,000 fish, and they're depreciating or decreasing at a rate of 10%. Blah, blah, blah. To be able to do that, you have to be able to do doubling, tripling, half-life. You have to be able to do the compound interest ones. How do you know it's compound interest? Because it says compounded in it. You have to be able to do the earthquake. And the decibels. And sometimes they just give you a random word problem with a random formula, and you have to plug it in, right? Now, what else could they give you? They could give you something like this. Log A of 2 equals Z. And log A of 3 equals Y. Okay, they can give you that. And they'll say determine log base A of 72A cubed. Now, what I need you guys to recognize, and I keep saying this over and over and over and over and over, is this is log base A of 72A cubed. What is happening with the 72 and the A cubed? What's in between them? Multiplication. And then I go to my formula sheet and I say, okay, if I have two things multiplied, what could I do? It's on that one, on the 30-2, it's on this one, on the 30-1. I have two things multiplied. What can, oh, I can separate them by addition. It literally says that, right? If I have a 1 in front of my log, you see how I have a 1 in front of my log, and I have two things multiplied, I can separate them by addition. What if I didn't have a 1 in front of my log? What if I had a 4 here, which I'm going to erase? What would I have to do before I could split them up? Bring the 4 up as the exponent and distribute it in, right? Then you can separate. You can only separate when there's 1s in front of your logs. That's what that whole, all those formulas, if you look, they all have 1s in front. And if they don't have 1s in front, you give them the power rule to make it have a 1 in front. Okay? We're not teaching that 4. I just wanted to say what would happen. Okay. So I know that I can separate that. So I can go log A of 72 plus log A of A cubed. Is that helpful in any way? I hope the log A of A cubed screams something to you. What does it scream? What's the answer of A to the A to the 3? It's just 3, right? A to the A to the 3, B to the B to the 3. And if you forget, can we not put the 3 here? And log A of A is 1. So 3 times 1, which is 3. So at least I hope you see that that's a 3. Okay? So log A to the A to the 3 is 3. Cool. We have that. Now the number 72. Well, let's see what they gave us. They gave us, if I can go log base A of 2 of something, if I go log base A of 2, I can replace any log base A of 2 with a Z. And I can replace any log base A of 3 with a Y. And I have log base A of 72. Awesome. But if it was log base A of 2 or log base A of 3, I can replace, correct? Can 72 be broken down into 2s and 3s? What? 72 is 2 times 2 times 2 times 3 times 3. Okay, if you don't know, go 72 divided by 2. Okay, 36. Divided by 2, 18. Divided by 2, 9. 9 is 3 and 3. So it's 2, 2, 2, 3, 3, right? That's what I can break it down. And people are like, why'd you break it down into 2s and 3s? Because there's what here? 2s and 3s. These are a huge hint as to what the heck you have to break them down into, right? So instead of 72, I am going to write log base A of 2 times 2 times 2 times 3 times 3. And what can I do when I have things multiplied? Add them. Add them. So I get log base A of 2 plus log base A of 2 plus log base A of 2 plus log base A of 3 plus log base A of 3, and then just plus the number 3, right? What can I replace log base A of 2's with? And what can I replace log base A of 3's with? Y. So I'm going to get Z plus Z plus Z plus Y plus Y plus 3. which I can rewrite as 3z plus 2y equals 3. Well, that's a lie. Plus 3. And that would be my simplified version. So we can split, right? And then one last one that I want to go through. Tomorrow we're going to go through log graphs, exponential graphs, radicals, rationals, and adding and subtracting. We're going to try and get through it all. Okay? Is that enough studying, though? 80 minutes with Mrs. Lepp? No, it's not. Okay? It's not. You can try it. It won't result in good things. But if you want to, you can go. All right. Taking those and redoing them till you can do them without errors, is that a good way of studying? Yeah? Can you find ones that match this in your textbook at the end of the textbook? Like at each section? Yeah. If you want different numbers, there they are. Okay, this one I want you to do. Log base 6 of log base 2 of log base 3 x plus 1 equals 1. And this will say solve. And this looks hella overwhelming, but it is not. You just have to work your way from the outside in, converting exponential. How many logs do I have? How many single logs? 3. I'm going to have to convert to exponential 3 times. However many single logs you have embedded is how many times you have to convert. So, what does that mean? Pretend that's just what's inside your log bracket, right? We're just pretending that's what's inside my log bracket. I'm covering it with my hands. How do I convert this to get that log to go away? 6 to the 1 equals dashed red lines, right? 6 to the 1 equals what the dashed red lines are. Is it not? If this is just what's inside that log base 6 of something equals 1, I can go 6, base my log becomes base my exponent, 6 to the 1 equals the red dashed line. So my next step is to get 6 to the 1 equals log base 2 of log base 3 of x plus 1. And 6 to the 1 is just 6, correct? Okay, I got rid of one log by converting to exponential once. I'm going to get rid of the next log by converting to exponential again. Last log by converting to exponential again, right? So now this now is my dashed red line. Correct? I want to get rid of the log base 2 of 6 and the red dashed line. So how do I convert this? Covering this up with my hand, the red dashed line. What do? 2 to the 6 equals dashed line, right? 2 to the 6 equals log base 3 of x plus 1. What's 2 to the power of 6? 30, 64. So now I get 64 equals log base 3 of x plus 1. Now we're just back to normal math. Kind of ugly, but what do we get? 3 to the 64 equals x plus 1. So then I just have to subtract 1. Seems hella overwhelming if you don't take it piece by piece by piece. I'll always cover up my little bracket and convert as if that bracket isn't as awful as it is. The bracket is awful, I'm not going to lie. Then I do the next one. Then I do the next one. So you convert as many single logs as you have to get rid of. This might get mad at me. And if it's a multiple choice, they're going to leave it like that, just so you know, 3 to the 6 and 4 minus 1 or something like that. Because it's e to the third. So this is 3.4. Oh, this is 3.43 times 10 to the 30, right? So they'll operate it. So your job tonight is to go through and be able to do everything we did today without looking. Everything we did today and word problems. I wouldn't touch radicals, rationals, other functions, or graphs tonight either. Because when you say too much, that's just too much. Your brain can't take in all that information in one day. I have to study exactly what we did today until you can't make ellipses. And word problems, right? That's still a lot to cover. And then tomorrow we do graphs, laws and exponentials. The 2 radical lessons, the 2 rational lessons, the 2 other functions.